Chapter 3. Chemistry of Joy, the Orchestra of Molecules. If the brain is a joy-generating organ, then the neurochemicals it deploys are its instruments. And joy, it turns out, is not played on a single instrument. It requires an orchestra, a coordinated ensemble of chemical signals, each contributing a distinct quality to the overall experience, each necessary in its own way, and each capable of being either amplified or suppressed by circumstance, habit, thought, and relationship. Understanding the chemistry of joy is not a reductive exercise, reducing the richness of human experience to mere molecules, but an illuminating one. When you know what these chemicals actually do, the felt experience of joy stops being mysterious and starts being legible. You begin to understand why certain things reliably produce joy and others do not. You begin to understand your own emotional landscape with a clarity that is itself, in its way, joyful. The four most discussed neurochemicals in the context of positive emotional experience are dopamine, serotonin, oxytocin, and endorphins. To these, we should add GABA and the endocannabinoid system, less celebrated but no less important. Each of these plays a distinct role, and together they constitute the chemical profile of joy in its full range. Dopamine, the engine of wanting and discovery. Dopamine is the most famous neurochemical in popular culture and also the most misunderstood. It is routinely called the pleasure chemical, but as we touched upon in Chapter 2, this description misses the mark significantly. Dopamine is more accurately described as the brain's signal of prediction, anticipation, and motivated pursuit. It fires most strongly not when you receive a reward, but when you encounter the unexpected prospect of a reward, when something good happens that you did not fully anticipate, or when a cue in the environment signals that something rewarding is about to be available. Neuroscientist Wolfram Schultz, in landmark research conducted in the 1990s, demonstrated that dopamine neurons in the VTA fire in response to prediction errors, specifically to rewards that are better than expected. When a reward is exactly what was anticipated, the dopamine signal is muted. When a reward is worse than expected, dopamine neurons actually reduce their firing below baseline. This is why novelty is such a reliable joy trigger. Novelty is, by definition, something you could not have fully predicted, and unpredicted goodness drives the dopamine system harder than anticipated goodness ever can. In the context of joy, dopamine provides the forward-leaning energy, the engagement, the curiosity, the drive to pursue and discover. It is the chemistry of the scientist excited by a new hypothesis, the child reaching for an interesting object, the musician beginning to improvise. It is present in every form of joy that involves exploration and engagement with the world. But as Berridge's work makes clear, dopamine alone does not produce the warm, satisfied glow of deep joy. That requires the activation of the opioid system, a different chemical register entirely. Serotonin, the stabilizer of well-being. Serotonin's role in joy is quieter and more foundational than dopamine's. Where dopamine provides the spark and the surge, serotonin provides the steady background glow of emotional stability and well-being. Serotonin is produced primarily in the raphe nuclei, a set of small structures in the brainstem, and it projects to virtually every region of the brain, making it one of the most widely distributed chemical signals in the entire nervous system. Approximately 90 to 95% of the body's serotonin is actually produced in the gut, where it plays important roles in digestion and immune function, which is one reason why gut health and emotional well-being are so deeply interconnected. In terms of joy, serotonin's most important function is what might be called emotional floor setting. It establishes the baseline level of positive effect on which other emotional experiences are overlaid. When serotonin levels are adequate, the world feels manageable, even beautiful. Small pleasures register more readily. The capacity to feel joy is accessible. When serotonin is chronically low, as it is in depression, even genuinely joyful events can fail to produce the emotional response they would ordinarily generate. This is the experience of anhedonia, the clinical term for the inability to feel pleasure or joy, which is one of the defining features of major depressive disorder and which represents, in neurochemical terms, a failure of the serotonin system to provide the stable positive velocity background against which joy can arise. The most widely prescribed antidepressants, selective serotonin reuptake inhibitors, or SSRIs, work precisely by increasing serotonin availability in the synaptic gaps between neurons, which is why they are effective not just at relieving depression but at restoring the capacity for positive emotional experience. Oxytocin, the chemistry of connection and trust. Oxytocin is perhaps the most socially significant of the joy-related neurochemicals. Produced in the hypothalamus and released into the bloodstream by the pituitary gland, as well as acting directly within the brain, oxytocin is the chemical of social bonding, trust, and the warm, expanded sense of connection that characterizes relational joy. It is released during physical touch, during sustained eye contact, during the act of giving, during sexual intimacy, during breastfeeding, during cooperative activity with others, and during experiences of shared emotion. Its presence transforms the neurochemical experience of social interaction, reducing the anxiety signals generated by the amygdala, the brain's threat detection center, and increasing the felt sense of safety, openness, and warmth. The joy that arises in genuine human connection, the joy of being truly seen, of belonging, of shared laughter, of the particular pleasure of a long conversation with someone who understands you, is oxytocin-mediated joy. It has a quality that distinguishes it clearly from dopamine-driven joy. It is warm rather than electric, deepening rather than escalating, and it tends to produce a sense of expansion toward the other person rather than a heightened awareness of the self. Research has found that oxytocin not only makes positive social experiences more rewarding but also makes people more generous, more trusting, more attuned to the emotional states of others, and more prosocial in their behavior generally. In this way, oxytocin creates a virtuous cycle. Joy in connection makes us more socially engaged, which generates more connection, which produces more oxytocin, which deepens joy. Endorphins, the body's natural opiates. Endorphins, the word is a contraction of endogenous morphine, meaning morphine produced within the body, are the brain's natural pain-killing and euphoria-producing chemicals. They bind to the same receptors in the brain that are targeted by opioid drugs such as morphine and heroin, which is why their effects, a warm, glowing, slightly floaty sense of well-being and pain relief, can be intensely pleasurable. Endorphins are released during intense physical exercise, producing what athletes call the runner's high, during laughter, during sustained social bonding, during the consumption of spicy foods, which trigger a mild pain response that the body compensates for with endorphin release, and during certain kinds of deep emotional experience, including crying. In the context of joy, endorphins are particularly associated with what might be called embodied joy, the kind that is felt strongly in the body, that produces a physical sense of glow and warmth and ease. They are prominent in the joy of vigorous physical play, in the joy of shared laughter, and in the complex, bittersweet joy that can arise during emotional catharsis. Importantly, endorphins and oxytocin appear to interact synergistically in the context of social joy. Shared physical activity, shared laughter, and physical contact each trigger both systems simultaneously, which is why these experiences tend to produce an especially rich and satisfying form of joy that outlasts the activity itself. GABA and the endocannabinoid system, the chemistry of ease. GABA, gamma-aminobutyric acid, is the brain's primary inhibitory neurotransmitter. Its function is to calm neural activity, reduce anxiety, and produce a sense of ease and quiet. In the context of joy, GABA is the chemical that prevents joy from tipping into overwhelm. The high arousal of intense joy can, in its absence, become anxiety or agitation. GABA's calming influence creates the neurological floor beneath excited joy states, producing the quality that distinguishes genuine joy from mere excitement or mania, a settled, grounded ease that coexists with a positive activation. The endocannabinoid system, named because its receptors are also the targets of the active compounds in cannabis, is a less commonly discussed but deeply important player in the chemistry of joy. The brain produces its own cannabinoid-like molecules, called endocannabinoids, particularly anandamide, whose name derives from the Sanskrit word for bliss, which bind to CB1 receptors throughout the brain and body. The endocannabinoid system plays a role in regulating mood, appetite, pain, memory, and, crucially, the experience of what researchers sometimes call the glow of joy, the soft, diffuse, non-directed sense of well-being and openness that can follow positive experiences, and that is distinct from the sharp activation of dopamine or the warm bonding quality of oxytocin. Anandamide in particular appears to modulate what neuroscientists call hedonic tone, the background pleasantness or unpleasantness of one's general experience, and its levels are reduced by stress and increased by exercise, meditation, and social connection.